Hello and welcome. Today we're going to be talking about how to choose detection in 2026. A lot has changed over the last few years, but the one thing that doesn't change is physics. So I wanted to start there. If you're trying to detect something, and there are multiple industries that do this, it could be anything from a golf ball to traffic, but there are a couple different things you should look at. One is, what kind of sensing energy are you going to use? Are you going to use active or passive? So active, you could think of this like a headlight on a car. So you're sending energy out and then reading the return. Passive, you could think of this like your eyes. You're just getting energy from the environment. And if you think of what we actually use to detect traffic, active, you could think of this as LiDAR and radar. Passive, cameras with no spotlight. So that's probably a good bounding condition for you. The second thing to look at is, what type of wavelengths are we going to be detecting? So in the visual spectrum, we're all familiar with this. This is this nice rainbow. You get a wide range of frequencies that you're detecting. And in this case, around 380 to 750 nanometers, but you get that wide range. And so that's important to think about in terms of context information. If you want to tell the difference between a city bus and a school bus, one's yellow, one's maybe blue, that color could be a critical piece to that. Now, if you have infrared, so this is something that we can't see, you might have this in a security camera or maybe LiDAR. And infrared could be in a wide range of frequencies, but think of this around 850 to 1500 nanometers or so. The difference between visible and infrared, in visible, you have a wide range. Infrared, you tend to pick one. So you tend to pick one frequency. You're going to have a single frequency. If you had an old LED flashlight and you shined it out in the dark and it was like one of those cold blue flashlights, you saw what this looks like. It's single frequency, it's long shadows. It's kind of this eerie experience. So that's kind of IR, single frequency, a little bit offset from visual, but very close to the visual spectrum. If you compare that to what we look at it as radar in the traffic industry, this would be like 24 to 60 gigahertz, technically in the microwave band. This is a different frequency, different energy levels that are going on here. So you're going to see different things from a physical point of view. And so if you convert that into what we're going to be talking about today, a vision-based system or a camera-based system is going to be using the visual spectrum. LiDAR is going to be using IR, and radar, what we call radar, is out there in that microwave band or millimeter radar band. So if you look at the impact of what that means for us in the industry, if you have a camera-based system and you have LiDAR, the differences between those two things are not going to be around the frequency difference. It's going to be mainly, is it active, or do you have a wide spectrum to choose from? There are some trade-offs between the two of those. So in terms of resolution, just raw resolution, you can see similarities. But in terms of classification, now camera is going to give you more context in your image. It's going to give you your colors. It's going to give you things that we're used to seeing. And it's a little bit easier to process and figure out what's going on, and easier to figure out what type of vehicle is out there and what are you seeing. Is it a school bus, city bus, that type of thing. All weather detection, again, they're both in a very similar band. They're both going to be affected by the same types of weather. So if you shine a bright flashlight in the fog, you know what this is like. If you shine a bright flashlight in the rain, you know what this is like. So if you have an active source of energy, it doesn't really help you when you have so much diffusion and scattering. Both of them are going to have a difficult time in heavy weather. In nighttime, this is where you see the active source. So LiDAR is going to be a spotlight, essentially. And so that's going to work well at nighttime. Visual context favors the camera-based systems. And then, speed, neither one of them's really perfect because we do have radar. So let's flip in and add radar to that. And now you'll see a different spectrum altogether. So now the differences are mainly based on where it falls with regard to the wavelength, because now you do see things like being able to punch through the weather. You can punch through fog, you can punch through rain. And that's a big advantage with radar. Also, you're able to get very accurate speed of objects on the road. So these all have their differences. That's why some companies are leaning toward fusion. Now the fusion, when we talk about fusion, this is not that you have a box and you have a camera on one side of it and a radar on the other side of it. Fusion, from our point of view, is when you take a camera image and it's as a sensor, and you take a radar reading as a sensor and you combine them together using some kind of computing power. This is common in other industries where traffic's not the only one doing it, but traffic is exercising this. And when you take those multiple sensors and you combine them, you're able to sort of evaluate them and take the best of whichever sensor you're getting and add that in if you're object level tracking. So kind of gives you redundancy. You do have multiple sensors available to you, but then you are able to pick and get the stronger benefits of each technology. So that's what we mean by fusion. And we're going to be looking at this today in some detail. Helping me do that will be our speaker. This is Tyler Houston. Tyler, welcome to the show. Tyler is our solutions engineering manager. A lot of you who worked with NoTraffic probably already met him. He has a BS in civil engineering from University of Texas at Austin and PE and PTOE credentials. So Tyler, I'm going to turn it over to you and let you talk about detection in 2026.
Great. Thanks, Mike. Thanks for having me. So what Mike just went over is a little bit about the different types of detectors that are available in the traffic industry. And so we'll be talking about that today. But before we go into just pure detection, what I want to talk about is what if you could, with that same detection system, also see insights into citywide traffic operations through various traffic insights or live video feeds, or start to understand high-risk intersections through safety metrics like near miss or red light running, or even maximize that infrastructure utilizing some of the other applications that are available to it, or even having it optimize your timings in real time. And that's what we're going to talk about today. Now, before we jump into the specifics, I want to give a little background on NoTraffic. So our company was established in 2017. We do have offices in Tel Aviv and in Kansas City. And the industry is really starting to take note of what we're doing here because it's pretty unique in the sense that not only do we deliver detection, but we can do a variety of different applications on top of this. And you can start to see this notice in the hundreds of agencies across the United States and Canada who are starting to use NoTraffic. So currently we're installed in over 40 states, and we're also installed in Canada. We have various approvals across North America. So we have TxDOT, FDOT, Caltrans, and then other various state approvals. And we are increasing our number of agencies that we're installed in every single week. Now, what the NoTraffic system looks like once we're installed at the intersection, it acts as a typical detection system, what most agencies are familiar with. So we have one sensor per approach, providing stop bar and advanced detection. So for a typical 4 approach, you're going to see 4 sensors. A really unique thing about NoTraffic is that one of those sensors is actually going to be a V2X enabled sensor. So that basically guarantees that in the future, once an agency starts to do connected vehicle applications, they will be future-proofed for those types of applications. We also have a Nexus unit that goes inside the traffic signal cabinet. It connects directly to the traffic signal controller, basically provides detection calls to the brain of the intersection. It also has a built-in LTE modem and Wi-Fi and Bluetooth connectivity. Now, the entire NoTraffic system is built upon best-in-class detection. And so this starts with our sensor units, which are a fusion of video and radar. And so with the 2 different types of sensors, like what Mike was saying, it gives us really accurate detection in all different types of conditions. It also means with one sensor, we can do stop bar and advanced detection per approach with one sensor. And then in addition to just vehicles, we can also do VRU detection, which includes bikes and pedestrians. Now, going a little bit deeper into the 2 different types of sensors, we use a radar, a 60 gigahertz radar. So it's a high resolution radar, which allows us to detect all different types of road users from pedestrians all the way up to heavy vehicles. So it gives us really accurate distance and speed. And it penetrates through weather nicely to get accuracy in all different types of weather conditions. Now we fuse this with video, and that is that's what allows us to object-based detection. It allows us to classify and track users. So not only vehicles like buses, trucks, and regular passenger vehicles, but also bicycles and pedestrians. And with those classification and tracking metrics, we can also create things like turning movement counts, performance measures, safety analytics, etc. So we fuse both of those 2 different types of sensors into one output fusion file, which gives us very detailed information of every type of object, which includes location, speed, heading, what lane they're in, what type of road user it is, and then we're doing this in all different types of weather conditions. Now, building on this accuracy in all different types of weather conditions, this could be anything that gets thrown at these sensors. So it could be things like fog, sun glare, snow, nighttime conditions, or even headlights at night, which can traditionally be challenges for existing video detection systems. Now, just looking at what our detection looks like, what you can see is we're detecting vehicles, both with video and radar. So the video is going to be those bounding boxes, and then that radar is going to be those white boxes and radar lines. Then you can also see that we're detecting bikes and peds. But what happens when it does not turn into a clear day? So something like fog. So this is what you can see here, where there's no bounding boxes on that approach. And a lot of that heavy lifting is actually being done by our radar. So with that radar, we're actually able to detect that vehicles are there and keep this intersection operational by activating those detection zones and continue to call and extend phases. We can also do this at nighttime and rain, even when the video is washed out at night. And that is because we also have that video or that radar in there. So you can see on those advanced zones that we are capturing those vehicles with the radar. And then you'll see that they'll slowly get picked up by the video and then our near-term radar. And then same thing for sun glare, a very common issue for a lot of different types of detection systems. Or if you were to have advanced zones here, they basically wouldn't be able to detect vehicles. But since we have the radar fused with the video, we're basically picking up all the vehicles on this approach up to 720 feet away, all the way to the stop bar, and then past the stop bar to track those vehicles through the middle of the intersection. Like we were saying, the system is installed as a traditional detection system. It's used to provide detection to the traffic signal controller. And so you get all the benefits and all the things that you're used to within the agency or within the history of all the different types of detection systems. So you can place stop bar and advanced zones. You can place bike zones. You can place counting zones for counting vehicles. We also allow real-time HD video streams of our sensors. And then you can also view vehicle and pedestrian phase status since we are connected to the controller. So going even further, you get all the traditional configuration settings. So you can label zones, change the output to the controller that they go to, type of vehicle triggered those zones, pulse versus presence, et cetera, et cetera. In addition, here you can see just a little bit behind the curtain of what you can do in terms of zone customization and monitoring. So we're actually annotating those lanes for approach. And then you can see over a live video status, the detection actually working and triggering those zones for visual verification of the detection. Now, in selecting a detection system, especially in 2026, a lot of agencies have kind of moved past the need for just detecting and sending an output to the controller. And so that's where the real benefit of NoTraffic comes in. So we coin ourselves as the AI mobility platform, world's leading. And that's because the system gets installed as a detection system, and that's our hardware. But once it's installed, we do have a software and support component that goes on top of it. And so this can be seen through our Mobility OS, which is our cloud-based traffic management platform, and then our other applications that are available through our mobility store. Now, the problem that NoTraffic is trying to solve is that traditionally in the ITS space, when you wanted to do a new solution, this would typically mean that you would need a new piece of hardware installed at the intersection. So for pure detection, for stop bar, you would have one set of detectors. You wanted to do advanced detection, you would set another set of detectors. If you wanted to do TSP or EVP, that would be more hardware. And if you want to do connect to vehicle applications, that would be another set of hardware. And so you can see as the number of applications you want to do at the intersection grows, so does the number of hardware devices. And what NoTraffic has done is we basically installed a future-proof set of hardware that you can then build software applications on top of. Therefore, you're future-proofing your investment that you make into the intersection with the NoTraffic platform. So going beyond our hardware capabilities, next is our software component. And so this is delivered through Mobility OS, which is our cloud-based traffic management platform. Basically allows agencies to manage all their intersections through one central portal. It allows them to get to things like turning movement counts, alerts that come through, basically view all this remotely in one central location. It also allows agencies to view live video from their intersections, see those alerts, and basically have access to all kinds of other applications that we offer through our mobility store. So included with Mobility OS, one of the main things that we get is, since we have AI algorithms running over our video and our sensors, we're able to detect anonymous, or basically any anomalous behavior that happens on the approach or in the middle of the intersection. So when we detect something like an overstay, basically a vehicle that's sitting on that approach, we generate an alert for that. That gets sent to our NoTraffic Operations Center, which we'll talk about a little bit later. They'll tag that as just a generic overstay or a vehicle that's sitting there. Traffic incident, maybe a roadwork construction, or anything that's happening within that field of view. So it gives you a little bit of operational awareness into what's happening at those intersections. In addition to just pure detection, we are also counting vehicles that go through the intersection. So you'll have access to traffic counts, basically provides total volume, approach volume, and turning movement counts, all by classification. Now, this can be viewed in Mobility OS or downloaded for further traffic analysis. And this traffic count basically acts as a permanent count station for that intersection. So traditionally, traffic engineers would need to go request traffic counts from a data collection company. If you were to have no traffic at your intersections, you're basically getting a permanent count station that can be used for traffic analysis. And lastly, with Mobility OS, we are getting a base set of signal performance through our data analytics. With this, you'll get arrivals on red and arrivals on green for coordination health, max approach delay, average approach delay, and level of service. So we talked about our hardware. That's based on our traffic detection system, our future-proofed hardware, our software, which is Mobility OS, and our mobility store. Now, the third component of the NoTraffic platform is our NoTraffic Operations Center, which provides proactive monitoring and support of all of our hardware. So when you get the NoTraffic system, we do have a built-in LTE connection, which provides communication from that nexus up to Mobility OS. But it also allows us to provide proactive monitoring of all of our devices out in the field. And what this leads to is basically peace of mind that all the hardware that you have deployed out there is going to be operational, powered on, and working properly. If some of our hardware starts to lose connection, maybe it loses power, our NOC team can actually proactively detect these issues and respond pretty quickly. They have the full capability of remote troubleshooting. And if they cannot fix something remotely, that's when they'll reach out to an agency and actually have them go out and troubleshoot that device. And the huge benefit of this is it acts as a force multiplier for the traffic agency. You basically have another set of eyes and ears that's monitoring all the equipment and make sure it's working properly. It also lowers operational cost. Instead of getting a call from the field saying that something's not working, typically an agency that has no traffic will figure out that something's not working through a notification that comes through Mobility OS or from our NOC team. And 95% of the time, we can typically troubleshoot this remotely and prevent rolling trucks to actually go out to the intersection and troubleshoot this. In addition to be a cellular and cloud-enabled solution, the NoTraffic platform is designed with end-to-end security in mind. So all of our devices are hardened. We are also cloud hosted on AWS servers. For our Canadian agencies out there, we are hosted in Canadian servers. Additionally, the NoTraffic system does not collect any personally identifiable information. We do a single tenant architecture, so customer environments are not shared. And additionally, since this is a traffic detection system, it is enabled through the cloud, but it's not dependent on the cloud to run. So if we were to lose that LTE connectivity with our AWS server, the traffic detection system continues to operate like the traditional detection system. Lastly, we are a very security-focused company. So we are ISO 27001 certified, SOC 2 Type 2 certified, and we are TextRamp certified as well. Now, building on this Mobility OS, on the basic functionality, we also have a mobility store. Basically expands the functionality of Mobility OS. So it comes with a base set of features like traffic detection, traffic counts, and signal performance measures, also with those alerts and that knock team. But beyond that, we see a lot of agencies wanting to do a lot more with their detection system. And that's where our mobility store comes in. So we basically make available all kinds of different applications, such as a safety suite, performance analytics. We have communications that are available. We have optimization mode for real-time optimization of the traffic signals. And then we're building these out as we go. Now, the key thing with the NoTraffic system is that this is a future-proofed software-enabled solution. So once the hardware is installed, no additional hardware is required to enable any of these. It's just a software add-on. So it can be added on either at the time of purchase or any time into the future. Now, some of these applications include safety and performance applications. Now, what you're seeing here is one of our applications in our safety suite. This is near miss. So basically proactively identifying high risk areas through our trajectories that we're collecting from every road user. So we're analyzing the video and determining where the vehicles, pedestrians, and bike are moving within the intersection, looking at their speed, type of road user, and then using a post analytics process, we're seeing where you might have an unsafe condition within the intersection. So are pedestrians interacting too closely with vehicles? And they basically generate an alert that you can go back and review in the near miss application. Along the same lines, we have intersection safety insights as one of our applications. This application provides red light running statistics. We find this to be a very important application because about 165,000 people per year are involved in some kind of incident that is also caused by red light running. So with this application, you're able to identify high-risk intersections, use the data to identify intersections that have a high rate of running, the approaches that have a high rate of running, and what time of day we're seeing these. And then we prioritize those in different tiers of red light running. So with those tiers, you can see that we are basically recording the number of events where a vehicle crosses the stop bar during the yellow, stopping during the all red, and then a tier 3 stopping after the all red. So the NoTraffic suite not only provides detection, traffic counts, signal performance measures, and safety analytics, but what we're most well known for is our optimization mode. And what optimization mode is basically rethinking the way that we time signals. So if you would like to outperform your manual timing plans that you get from consulting engineers, being able to handle unexpected traffic events outside of your pre-established AM and PM peak plans, improve safety, and modernize the way that you time signals, then optimization is something that we would like to explore with you. The way optimization mode works is we have a local optimizer that runs on the Nexus unit at the intersection that evaluates thousands of scenarios up to 2 minutes into the future and adapts those signal timings in real time based off the traffic demand at the intersection. We use policies set by the agency to prioritize what timing should be done at that intersection. So do you want to prioritize movements along the main line, side streets, transit, pedestrians, etc. Diving a little deeper into how that optimization algorithm works. So it's running thousands of scenarios up to 2 minutes into the future, selecting the scenario that produces the lowest delay. So our goal is basically to minimize delay for the intersection as a whole. Now, how we select how to prioritize is through policies. And those policies are basically a weighting to that optimization algorithm. And we can do this to prioritize that main line, minimize the wait times for pedestrians, minimize the wait time for public transit vehicles, or just focus on getting vehicles through busy corridors. It is a decentralized approach, so it's a pretty big advantage compared to traditional adaptive systems. It doesn't require a central system to do all the decision making. It's decentralized, so each intersection is making its decisions by themselves. And then we're using our built-in cell connection to send platoon messages back and forth, basically a way for each of the intersections to communicate, hey, I'm sending you a platoon. This platoon will be there in 30 seconds. There's 20 vehicles there. Now that downstream intersection can say, okay, I know I have 20 vehicles coming in. They'll be here in 30 seconds. Now I need to make the best decision on where I need to be to accommodate that incoming platoon. Now, we've done optimization in many different agencies in North America. One example I'd like to share with you is Oklahoma City. So they brought us on because they were traditionally doing AM and PM plans throughout the city, but they wanted to test out what they could do with a modern optimization system like NoTraffic. We went in and we basically installed the NoTraffic system. We let the system run regular timing plans for about a month. During that time, we basically used that existing data that we collected from those intersections and did an offline model where we could basically create a calibrated existing condition model. We compared that to our optimization mode offline. We shared the results with the city, and then we went ahead and turned this on out in the field. And once we turned it on, we saw some pretty significant benefits for the city. So on the specific corridor, we saw about a 24% reduction in overall delay throughout the entire day. We saw up to a 41% in key areas during key times. And during the PM peak, which is their most significant rush hour, we saw about a 20% reduction in delay. This resulted in about a $35 million economic benefit, big reduction in CO2 emissions, and almost a 280 to 1 economic return on that investment. Moving that over to the city of Houston, who's dealing with similar issues, but had one more use case. The city of Houston was looking for something outside Energy Stadium, which is where the Texans play. But in addition to where the Texans play, they also host many events like concerts. In this same area, there is a medical district and a big shopping center. So they wanted a system that could not only handle regular commuter traffic to serve the different businesses and hospitals along that corridor, but also a system that could automatically respond to event traffic like game day or concerts. So we did the same thing. We basically installed our system, let it run for a month or two. In the meantime, we were collecting data both for AM and PM traffic, also for events. And we tested our optimization offline. So we got a good idea of how it was going to run before we actually turned this on in the field. And after we turned it on, we saw some pretty significant results as well. So up to a 52% reduction in delay in key locations. This was during event traffic and PM traffic, but just for AM PM traffic, we still saw pretty significant reductions in delay. Since we were also tracking safety metrics on this corridor, we were able to correlate turning on optimization mode with a reduction in red light running. So we think that's because we're better serving traffic, that drivers were less likely to run the red light. During game days, we also found that it's more likely that officers were less likely to take control of the intersection and put it in manual control because our system was effectively managing that game day traffic. And it helped key initiatives for the city, including Vision Zero, Safe Streets, and just processing vehicles coming out of Energy Stadium during events. So we've seen similar results across many different agencies in North America. So for everyone listening here, if you'd like to learn more about the NoTraffic system and where we've been installed and some of the things that we've seen in places like Tucson, Phoenix, Santee, Sugar Land, University of British Columbia, we want you to go to our website where we have different use cases there. You can find full briefs on what we've done, the results they've seen, and the benefits that a lot of these agencies have been seeing. And with that, I will pass it back to you, Mike.
All right. Thanks, Tyler. So to summarize everything into one little slide here, you still have detection. You still have to think about your detection solution. And so that's in the center of it all. So we're not saying the detection goes away, but at this point in time, being able to see objects on the road, that's kind of like the table stakes. That's just the entry point. What agencies are looking at now is how do you future-proof this? How do you get advanced capabilities? And that's mainly what we're talking about today. And this is a core requirement of what you should be looking at in 2026. So how do you get the most out of your infrastructure? How do you go and make a 2-lane operate like a 2.2 lane? And that's where the optimization product comes in. How do you improve safety and traffic flow and emissions? And we talked about the red light running application. We talked about near miss. I think you saw there's a whole page of applications. We didn't go through all of those because that would take a while. But if you're interested in learning more about any of those applications, you can go to our webpage and look, and we do have flyers on most of those that are released. But then you also have to think about protecting this system. So we do layer this in 2 layers of protection. One is the service and maintenance, and that's what we call our NOC, No Traffic Operations Center. And what they do is they monitor and maintain the system and make sure it's up and running. They're like an IT agency that is just working for you, and you don't have to pay extra for that. And then you've also got the security level, cybersecurity level, and that's where the SOC 2 Type 2 compliance comes in. That's where the text ramp comes in. So everything is secured with the latest and greatest security. It's monitored and maintained. And all of that together kind of gives you a future-proof, future-ready product, gives you great detection, which you talked about, leveraging the best of both worlds in terms of the camera and the radar, but then layering all of this on top so that you can do what you want to do to improve the performance on your streets and to improve the safety. If we didn't get to something, ping us. We're pretty transparent and pretty easy to get a hold of, and we'd love to field your questions.
Sums up great. Thanks, Mike.
All right. Thank you, everyone, for joining us, and stay tuned for other great sessions from NoTraffic.